Welcome to C2.1.3 Pure and Impure Substances. So today's learning objectives are to explain what pure means, explain what a mixture is, and to be able to use melting point data to determine whether a substance is pure or impure. So first of all, our definitions. So when we talk about pure in everyday life, sometimes we talk about like pure orange juice, for example, and we mean that it doesn't contain anything man-made. In science, when we talk about pure, we mean that it only contains one element or compound. So orange juice, for example, would not be pure in a scientific sense because it's not just one element or compound. And to understand this definition, we need to revisit our key stage 3 science and remember that when we're talking about an element, we're talking about a substance where all atoms are identical. And when we're talking about a compound, we're talking about a substance that contains more than one type of atom, so they're not all identical, but that they are all chemically joined together. Because if there's more than one type of atom but they're not chemically joined, then that would be a mixture. So when we talk about a mixture is impure. So impure means that it contains more than one element or compound. So we need to be able to describe how to use the melting point to determine purity. So by looking at the melting point, we can see whether something's pure or not. So when we add an impurity to a substance, it lowers the melting point, and it also broadens the range over which melting occurs. So if we talk about ice, for example, so our melting point of ice is 0 degrees C. So if there was something impure in it, that melting point would be lower. So the more impurity you've got, the lower it would be. So it would be lower than 0 degrees C. So it might be like -1, -2 degrees C. And it also broadens the range over which melting occurs. So if you have pure ice, then it will melt at exactly 0 degrees C. If you had impure ice, it might melt somewhere between -2 and -1 degree C, for example. And this is the basis for when it snows and there's ice and snow outside and we add salt to it and it causes it to melt because it lowers the melting point. When we do an experiment in school, I'll talk about that in the next slide. I'll show you the experiment setup. When we do that experiment, it's important when we measure the melting point to do two things. First of all, we need to heat the substance slowly, and that's so the whole of the sample increases in temperature, because if you heat it quickly, one part of it might heat up quicker than the rest. We also need to make sure that we stir it as it melts, because if we don't do that, then some of the sample might be at a different temperature. So stirring it makes sure that all the samples are at the same temperature. So here's a typical experiment setup that we could do in a school classroom to measure the melting point of a substance. So quite often we don't want to heat the substance directly in the flame because it's better to do it we want to heat it slowly, as we discussed on the previous slide. We want to heat the whole thing slowly. So the best way of doing it slowly is, instead of sticking it into the Bunsen burner flame, is we'd use a water bath. So we have this setup here where we have a heatproof mat to protect our table. We have a tripod on top of that so that we can hold the beaker, and we have the Bunsen burner underneath. We have the gauze in between the tripod and the beaker. So the beaker has some water in it, and then inside that water you have a boiling tube, and that boiling tube is going to contain the substance that's being tested, that we're trying to work out the melting point. It's also going to have a thermometer so we can measure the temperature. So what you do is you'd set up the equipment that's shown in the diagram. You would start the timer, light the Bunsen burner, turn it onto the blue flame, but we try and put it on that kind of borderline where it is blue, but it's not that roaring, really vigorous blue flame that's going to heat it too quickly. And you'd record the temperature every 20 seconds or so that we could see how the temperature changes. And when we do that, we would normally plot a graph of the results, and we would get something that looks like this. So when we heat a substance and it's not changing state, then you get a diagonal line. So on the left-hand side would be our pure chemical. So we've got our solid, and we're heating it up, and as we provide heat energy to that solid, it is going to increase in temperature. At the point where it melts, then that temperature, that heat that's being given to that chemical, instead of being used to heat the substance up and increase the temperature of that substance, it will be used to overcome the bonds between the particles. And so you get this plateau. So you get a horizontal line where the substance is melting. So that horizontal line on the left-hand graph shows where it's turning from the solid into the liquid, so where it's melting. So if it's pure, it's going to be, you can see on that left-hand graph, it's a horizontal line. So it melts at exactly one temperature. And if we compared that to our literature value, then it would be exactly the same. So if I was doing ice and it was pure, then it would melt at exactly 0 degrees C. On the right-hand side, we can see what would happen if it was an impure chemical. So it's a bit of an exaggerated graph that it probably wouldn't look that severe, but I tried doing a subtle version and it didn't show up very well. So what you can see is that if that was the same chemical, but the one on the right is impure, then the melting point is both lower and also broader. So instead of being a horizontal line, you just get a less steep diagonal line. So it's going to melt over a broader range of temperatures, and that temperature that it melts over is going to be lower than the literature value. That's all you need to know for this lesson. Thank you for listening. See you next time.